Hello everyone. In this exercise of the SolidWorks, we will we will create a sheet metal part as shown in the screen. This is a simple part of the sheet metal and thickness of the part is the 3 mm. This is 180 in this direction and 110 in this direction. They are they are the flanges also. Flange height are also you may consider it is 100 mm. Flange height is this flange height is this one. This is 40 mm and this is the edge flange 25 mm. Let us start. I go in the file. This is new part and this is the SolidWorks user interface. I make the plane white and unit system is the millimeter gram per second. This is this. I take the top plane. Top plane, sketch, center rectangle. We will create a simple sheet metal part as per drawing. This dimension is the 180. And this is the 110. Okay. And I go in the sheet metal. Sheet metal, to bring the sheet metal, right click on any tab and tabs, go in the tabs and there is the sheet metal. Click it. But my sheet metal tab is coming in my user interface. Okay. Sheet metal. Now I create base flange. This is the base flange. Thickness of the base flange, I am taking 3 mm as per drawing, but I am taking the direction reverse direction. Here you can reverse the direction in this way. K factor standard 0.5. Auto relief, we will not provide any auto relief here. Isometric view. Now I take the edge flange. Edge flange, taking this one. As per drawing, the height is 100 mm. I am taking the height 100 mm. This is the using default radius. You can change the radius, but I am taking 3 mm. This 3 mm radius is the inside radius. If you see this one, okay, and here flange length I am taking 100 mm. Okay, this is the they are the three option for the flange length. This first portion, it means the flange height is taken from this point, intersection of outer edge and outer edge of flange. This is the intersection. From intersection up to the flange, this length up to this is the outer virtual shaft. I am taking this option, outer virtual shaft. Okay, 100 mm as the height. And the trims, I am taking the band inside, metal inside. This is the outside, this is the band outside, but I am taking metal inside. This one. This is a 100 mm height. I am taking the flange thickness. If the measure this is, then a radius is a 3 mm. Okay, as per drawing. Now I am taking, firstly I am taking these flanges, four flanges. Firstly I will make two single flange, edge flange. Edge flange. Okay. And this one. Same way, use default radius. I am taking the radius is 3 mm. Okay. And the flange length I am taking it this time 40 mm. And this outer virtual shaft. This is the outer virtual shaft. I am taking this option, outer virtual shaft. This means it means metal is inside. Metal is inside. I am taking inside. No, as per drawing, you will see the metal is outside. Metal is outside. This is metal is outside. If you see, metal is outside. I am taking this. This band is outside. This one. Metal is outside. This one. Okay. And the flange length is this one. Flange length is 40 mm. Outer virtual shaft from this end. And this band is outside. This means flange moves shifted by 3 plus 3, 6 mm. Okay. I am taking. These are the two flanges I have made. Now I am editing this flange. I am editing this. I am editing first flange. First flange, edit flange. This one, this window pop up. I am taking this. As per drawing, this dimension is 20 mm. And this dimension is also 20. This dimension is 20 mm. Okay. Back 40 mm height, flange outside. Okay. Now I am taking another flange, edit flange. This time I am editing this flange. Small dimension from outer dimension, this one, 20 mm. Back 40 mm height, metal from outer virtual shaft, this one, and band outside. Same radius 3 mm, height 40 mm, and I in this way. This I have made isometric. Okay. Now what I will do, as per dimensions, as per drawing, I am unfold, fix space, this one, and collect all bands. I am using automatically, it takes all the bands, 1, 2, 3, 1, 2, 3, 4 bands is collect, system automatically detects. Okay. Now select this face, sketch. I am taking corner rectangle. This one. Okay. And select this line vertical. Now it comes on. This dimension is 70 mm. I am taking 70 mm. Okay. Now I am mirror it. Mirror entity, select entity, this one. Make sure copy should be checked. Mirror about this line. Now sheet metal, shoot cut. Blind, this link to thickness. This should be checked. Blind, link to thickness. Okay. This way you cut. And again, fold. Fold. This fixed face automatically detects the systems. Bend, unfold. Collect all bends. This automatically detects. Collect all bends. And this way, I made this flange. If you check the height of these flanges, measure this one and this. (40 mm) delta y, 40 mm. This way. Okay. And radius, measure inside radius. This one, this. This radius 3 mm. This radius is 3 mm. You can see here. Sheet metal. Isometric. Now I select this face. This place I am taking the in sheet metal break cord. I am taking this 10 mm. Select this face. You select the whole face. This way, chamfer provides. Okay. As per drawing, there is a 10 mm chamfer here. Okay. Now I select this face. Sketch. Just I am taking construction. Okay, I am taking the center point slot. This one. Dimension, this is 2.5 mm, 2.50. Okay, and this arc length I am taking 15 mm. Okay, and this radius I am taking this radius 20 mm. This is 20 mm. And taking this line vertical. One more line I am taking. Dimension, this line 45 degrees. And dimension of this I'm taking 40 mm dia of this. And select this line, vertical 35. Dimension I am taking 50 mm. This is fully defined. It means center is the mid of this flange. Okay. Now I am taking sheet metal, extrude cut. Now this time I am taking through all. This one. Okay. I am taking. Now I take the front plane, future, mirror, select the future, this one. Okay. Now I am creating another plane, future, this one, plane, select this face. I am taking the distance of 50 mm, but is going reverse direction. I am flipping upside. Now this plane. Now future, mirror, select plane 1, which I have created new plane. Futures to mirror, both plane, this one. Mirror, I have created this one. Hide the mirror plane. In this way, I have created this. Now, another flange is at a distance to 25 mm. This flange, sheet metal, edge flange, this one. Radius is 3 mm. This is 25 mm. But metal is inside. If I take left, this one. Metal is inside. Metal is inside. Okay, metal is inside. Height is 25 mm from here. Outer virtual shaft from here to end of this one. Thickness 3 mm. Inside radius 25 mm is the edge length, and metal is inside and inside this one. Okay. The same way, added. Same way, this one, this one, this one. Metal is inside, outer virtual shaft 3 mm. Height is 25 mm. This way, I have created two flanges. There is 4 holes of 5 mm dia here. You will see 4 holes. This one dia, 4 holes, 5 mm dia. Center is the 20 mm, 40 mm hole. This one. So first select this. This is 40 mm. Fully defined. This one, sheet metal, extrude cut, blind. If you select the blind link to thickness, it means cut will take place only in the up to thickness. This one. Now break corner. In the corner, break corner, select all the faces. This one, or this one. This way 10 mm chamfer. Now there are 4 holes. Select this face, sketch. Midpoint, select vertical. Okay. This height is 12.5 mm. This height and this This will be the 17 point by default. Okay, this one. Or you cut it, sheet metal, extrude cut, link to thickness, blind, link to thickness. If you take mirror, future, mirror, mirror, this is the mirror. Okay, now again mirror, I am taking the front plane, this one, and mirror this one. This way both take place, and this one. This we have designed in the simple. Metal you can apply from here. Click edit material. Yes, right. This one. Apply, close. This is the material. Edit appearance. You can give the edit appearance from here up. In Future Trim Manager, click here. Part, select appearance, and I select the basic. This way you can apply appearance from here. And in the flatten stage, the sheet metal, you flatten it, this one. This is sheet metal part. If you want to make a AutoCAD file for a further machining purpose, right click, export to DSF, export to DSF. Right click on this, right click on this part, export to DSF. This file is used in for AutoCAD purpose. You can give any name, flatten view, FLATTEN, flatten view. Okay, save it. You can decide the path, E drive, this one. This window comes in the sheet metal, in the left side, select the sheet metal, whatever features you required, you can select it, geometry, band, lines. If you want to select, there is no bounding tool, bounding boxes, this is the outer line of this one, this is the bounding box. If the origin you want to decide, you can decide it. Whatever feature you want to select, you can select from here and click OK. Now it will save this figure. See, this file is used for the machining purpose with AutoCAD file. Okay, DXF. Right. In this way we can save the file. This one and this. In this way we can design this created a simple sheet metal part with the help of the base flange, edge flange, and different cuts, extrude cuts. I have made this. I hope you would have enjoyed in this exercise. You please subscribe this channel and like and share also. Thank you. Okay.